Hey guys, welcome back to the shop. I'm going to start on our next small part here that we got to make. So a viewer of ours named Jason, he reached out to me and asked if this was a part that I would be willing to make for him. It goes to a vintage clawsing milling machine. He said it's for a number 8520 milling machine, clawsing. And he had contacted clawsing about this part and said that, or they told him, you know, they no longer offer this part, they don't make it or anything like that, but they did give him a copy of the drawing there so that he could make it himself. So that's what he sent to me. This is the actual drawing right here from clawsing, and it looks like this particular drawing was redrawn in 1953. So pretty old part, and I love the hand draftsmanship that went into making these prints like that. It's just really great looking handwriting and everything. I learned how to do this kind of stuff in high school, so that's why I can do it some, but I certainly don't have the kind of handwriting and being able to write the numbers like you see in a lot of these old drawings like this. People just really had a knack and a skill for doing this stuff back before everyone used computers to make drawings. But anyway, it's a knurled nut. It's got a 3/4 16 thread on the inside, and it's got a diamond knurl on the outside, and it's got a couple holes drilled and tapped. So Jason didn't actually send me any photos of like where this goes or how it's used on the mill. All I have is this right here. So we're just going to duplicate what it says on the drawing here and get this done for him. I'm going to use this piece of 4140 right here. This is one of the shafts that I had turned in the CNC lathe. This is one of the bad ones that was not on size. I had a messed up section right here on this undercut. So I had several of these where I was trying to get things dialed in and I didn't hit my mark. So some extra material laying around that we can use to make other parts. So we'll just chuck it up and use this in here and turn that and make Jason one of these diamond knurled nuts for his mill. So let's go over to the Precision Matthews and get started on this guy. So what we'll have as far as order of operations, I'm going to reface that, recenter it, and then we'll drill it, counterbore it. We'll use a 3/4 16 tap to tap it, and then we'll do the OD there. We'll have to turn the OD, turn a step on it, do the diamond knurl, and then once we get all those features done, we'll part it off and probably just chuck it back up to finish off the back side there. There's just going to be a pilot hole to get a pilot down through there. This is a 33/64 drill bit. That's going to give us a hole. The other side is drilled for 17/32, but I think I want to finish it with a boring bar. looking for an 11/16 diameter. That's tap size for 3/4. Looks like we got it, maybe a thou over. Put us a nice little chamfer there. Three-quarter 16 hand tap. And then we'll use the spring-loaded center to support it. And we'll have to put it into low gear there. All right, that was the plug tap. We're going to go back in there with the bottom tap. So it'll tap it as close as we can up to that shoulder. And I will put the spring center back in there just to support it, try to keep everything aligned. There we go, there's the bottom. All right. So what I'm doing, I'm using the boring bar, and we're finishing out the other bore, the 17/32 bore, with the bar, and just using a telescope gauge and a mic there to get it on size. This should be my finished cut there. We're gonna back off. Just decided to go ahead, since we had it set up true, go ahead and use our boring bar and our tools here to bore it concentric with our threaded features here. It's a drilled hole, so I don't know how critical it actually is, but we've got it there on 17/32, so there's 531. I think that's going to be close enough for a drilled hole spec. We'll get our OD turn to 1 1/8. I was looking to finish this at 1.130, just a little bit over, because we're gonna knurl it and then just skin the OD of the knurl to kind of make them true. And I landed on 130.5, so right about where we want it. Now we've got a little step there. Actually, there's a step on both sides of the knurl. I'll go ahead and get this one machined in, and we'll have to do an undercut on the other side I want to have clearance there for our knurl to be able to knurl the top without running into the other material there. 16 smaller by 1/8 back. Goes pretty quick, so you got to be careful there. And it's just sort of an undercut area. I think I'll use the calipers here to kind of see what we got. About 30 thousandths. $10, $20, $30. I think that's close enough to 1 1/16. All right, we've got a corner round to do on the corner at 1/16 radius. We need a chamfer there, and we still got to undercut that side. I'm going to use the parting tool there to generate the same undercut that we did right here. Actually, I don't want to spin it that fast. Let's slow it back down. See what we do here. Giving myself a little bit of extra room here. To our 0. Just cleaning it up. All right, so this is the knurling tool that I'm going to use right here. This is my trusty go-to, always seems to get the job done, and I like using these diamond knurls right there. They're more coarse, but they seem to always work well for every time. Usually when I want to knurl something, there's never really any kind of specs as to how coarse it is or anything. So I just kind of make these work because they're set up ready to go and they get the job done. So I've already got a 0 there. Yep, 0. And we'll go for it here. So we're going to run kind of a slow RPM. That's 130. Let me check. Yep, 130. We're going to feed 10 thousandths per rev, and I don't know. We'll go in somewhere between 20 and 30 thousandths on the depth, probably. I'm using the GoPro to give you this video because the other one would probably be shaking too bad for you to be able to see anything. And when I knurl, I usually don't disengage the feed. Yeah, that's looking nice. So I'm just using the on and off engagement there. All right, so now what I'm going to do is reach over here and reverse the direction of the feed. And we're just going to feed back that direction, and as soon as we start it up, I'm going to feed another 10 thou. All right, now we're on 20 thousandths, and then you just stop every now and then. I just hit the foot brake and inspect it. It's looking nice. That's looking pretty good. Let's go ahead and make another pass. Let's go another 5 and see how it's doing. Change the feed to forward direction. In 5. And I'm going to go ahead and I want to go ahead and put a little bit of cutting oil on here just to kind of help lubricate that. Remember, knurling is not cutting. You're just pushing the metal. I think we'll take our chances and go back the other way with maybe 5 more. Reverse it. All right, that's a total of 30 thou. I think I grabbed the wrong oil. I did. That was whey oil. That's why it didn't look dark. There's your cutting oil right there. All right, I'm gonna back out there, disengage my feed, because I think we've got a pretty decent knurl there. Oh yeah, that looks pretty good. So what we'll do is we'll run the tool over that just to clean that up and get rid of some of the burr feel off that, and just kind of make it all even. All right, I want to go in there with a chamfer, chamfer both sides of that. Trying to match up what I had there previously.
Zero.
Go into X0, it should line up again. All right, there's our chamfers there. I'm going to take this tool out, and I have a 1/16 corner rounding tool. This guy right there, that'll give us the radius that we're looking for the corner there. It's got a 3/8 shank. That's what this holder holds down on. 3/8 shanks. I'm just going to bring it up, eyeball at the center. It looks pretty good. All right, we'll slow it down a couple notches. That looks pretty good, right about there. All right. I think what I should probably do from here is, instead of parting it off, it would be easier to hold it just like this, because we have to drill and tap through here for 1/4-20 set screws. We'll tap it for 1/4-20. I'm assuming set screws go in there. And that way we can hold it, drill and tap it, and then come back to the lathe here and part it off. And at that point, our last stop will be to just rechuck it again here and face that back side off and put our chamfers on there. We've got our dial set, or division anyway. I've got a little dot here that I use, the ball oiler and a paint dot to indicate a 0 position. So I have it set on 180 right there. So drill and tap it one side on 180, rotate it to 0, drill and tap the other side. We're about to come over here to the spacer to do those 2 tapped holes. I'm just showing you how I find the center. So I got this turned ground and polished piece of Thompson hardened rod that I use for both a handle to be able to pick it up and move it, and also use it to find the center of it there as well. Find one side, we're gonna zero out the DRO. Pretty standard procedure for using a DRO on a mill. And then find the back side, kick it over. And then this is the axis right here. We're gonna hit, where's it at? Half there, and then axis there, 643. So we move our y-axis over until we get that on 0. And that's gonna be the center of the chuck there. So now we need to find the center line of where our drilled and tapped hole is gonna be in relation to the face here. That is gonna be 9/32 of an inch, or what is 9/32? 0.281. So we'll use this edge finder here. We'll find the edge. All right, we're gonna zero, and we're gonna move how far? 381 thousandths. 381, there we go. The extra 100 thousandths is half of the diameter of the tip of this edge finder here. This is 200 thousandths diameter edge finder. A quick visual reference with our stirret rule indicates that we are on 9/32 from the face there. So I think I'm going to do this in stages where we'll do the center drill to center it, put the drill in, drill it, and then tap it. But we'll drill it, rotate it, drill it, rotate it, and just keep going that route. All right, so let's get moving. It looked like it moved on me. Let me just make sure. No, it's tight. Okay. Just looked like it had moved. Maybe not. Just a little dab of cutting oil there. Come on. There we go. Zero. Now we'll get our tap drill in there. It should be a number 7 drill bit. Number 7 drill bit. That's tap size for a 1/4 20. Drop the table down a little bit. Another dab of cutting oil. Just using my dark cutting oil for this. Get the handle in a comfortable position. Rotate it back 180. And I did verify on the print again that these are 180 out. That's how they got it drawn. Okay. I think what I'm going to do is go ahead, just since we got that knurl surface on there, I'm going to go ahead and chamfer that very lightly so just help that tap follow through there. All right, we're just going to use a 90 degree chamfer here. Okay, that looks pretty good. Zero. That looks good too. All right, we'll find us a tap and tap it. All right, we're going to use a 1/4 20 gun tap here. This is a Cleveland brand. Just put it in the chuck and we'll power tap it. Rotate it around back to our 180. Maybe we'll tighten up the shot, get you a little closer for this one. All right, we're done with the milling. We'll go back to the lathe, finish this guy out. I just want to make sure that the tapped holes are deburred good. So I'm just going to do this like this. I'm going to use the bottom tap. Clamp it in the vise here. And just chase the holes there with the tap. All right, that should be good to go. Okay, let's get this parted off. So I'm going to use the Pee Wee Tools parting tool here. It's a carbide insert. And I've just touched the face there. Probably take 1 or 2 thou. I'm going to go ahead and let that tool come across there and just trim that face. Just like that. Tell you what, I'm going to do that again. And I'll back off of it. I'm going to zero out the readout right there. Clean that up one more time. We're 0. All right. Now, I'm going to move it in Z negative 1.072 inches. One 1.072 right there. All right, so what that's allowing us to have our 15/16 width plus the width of the parting blade there, since we touched off on the left side, and that's going to give us 10 thousandths there to be able to face that back side. All right, use our rule again to verify our width there, and that looks right. Just past the 15/16 mark on the rule. Got this bronze catcher rod that we're going to slide in there to catch it, and we're going to use some dark cutting oil. We are lined up. Here we go. I'm just going to feed this in by hand, by the way, and then use my right hand to keep it oiled. There we go. Yep, it's usually warm when you part it off. All right, so we'll just chuck this right back in there. We should be good on the knurl there, and then we'll go ahead and face this side, put our chamfer, our radius, and then that'll finish this up. All right, so let's measure our parted width there. 949, so 12 thousandths over. Okay, what we'll do is just touch it, take 10 thousandths off of it. Let's see if we can get it to run true on our knurl. Try not to over squeeze it here. Let's see how we look. All right, visually it looks like it's running true as can be. Get our face done first. All right, so I would call that a touch. Let's move in 10 thou. Going back with our corner rounding end mill. Just gonna pick this up by hand and kind of lock it in on center line. We are clearing the chuck jaws. This is our very last stop here. We just need to put a chamfer there. Just like that. I'm gonna feel it, make sure it's not rolling the edge. So I want to soften that up just a little bit there. Let me get the tool out of the way. Just using some of this 320 grit there. And I want to just soften that up. Sometimes even when you chamfer it, it kind of rolls a little tiny burr over it that you can feel. I'll go ahead and hit the face there to kind of brighten that up. Brighten up that radius there. Make it look a little bit nicer. And there we go. Let's take it out of here. It looks pretty good. It looks uniform. Let's see how thick we ended up since we just touched it and took 10. Where did we land? 939. So technically 1.5 thou wider than 15/16. That is close enough. Oh, look at that. Squared it up a little bit better. About 1/2 thou. Not bad. All right, guys, well, this is finished up there. We've got a completed special nut for our Clausing 8520 milling machine. I like the way the knurl turned out. I like the more coarse diamond knurl myself, even though the print there shows a little bit finer, a finer knurl, but I really don't think that matters there. I think that this is gonna be just fine visually. And of course, you get the grip on there from the knurl so you can grab it and twist it with your hands. I wish I knew exactly how it was used or what it was for on the mill, but unfortunately I just don't have that information at the time of making this video there. I'm sure some of you guys probably recognize it though and know what it's for and what it's used for. But I had fun sharing, making this for you, showing the little simple techniques using a manual lathe, the manual mill, and what it takes to knock out a little part like this. So that's it. We'll get this wrapped up, get it in a box, and get it sent to Jason so he can carry on with his mill project there. Hope you guys enjoyed watching this video, and I hope to see you again on the next job.